Firstly, thank you, Dr. S. Somnath ji, for gracing this event. And thank you so much, यहाँ पे जितने भी तमाम लोग हैं, सब्र करने का, इंतज़ार करने का. Before we begin, मैं एक announcement करना चाहूँगा. जो हमारी communication होगी will mostly be in English because we really want to know the great mind of Dr. S. Somnath ji, and I hope everyone is comfortable with that, and thank you for your patience again. But before I begin, it is such an honor for me, and I'm sure everyone present here, to be able to sit with you and get your perspective on something which made the entire nation proud. We've been saying this all day. And lastly, I would want to say, Chandrayaan-3 not only was such a moment of pride for the scientific community, but the entire nation. So my first question is related to Chandrayaan-3. And the success of Chandrayaan-3, the soft landing on the moon's south pole, is proof that India has been actively participating in lunar missions. What are the next milestones ISRO is aiming for in the lunar exploration? And what novel technologies are being developed for these missions?
Thank you, Vikram ji, for that question. But before I answering this question, I must thank the Chhatra Sansad organization and also all the people behind it for such a wonderful organizing this, this event for the benefit of young people of India. And also, having me here today, though it is a little bit late for all of us, but still I am really happy to be part of this. And thank you, Vikramji, for being here for all of us.
The honor is all mine, sir.
So let me answering the question that you asked. See, Chandrayaan was a journey that we started with Chandrayaan 1, 2, and 3. It's almost 10 years of effort that we reached now the Chandrayaan-3, the soft landing. Now, beyond this, we need to continue the effort in reaching moon in a big manner. I think you are already aware that the Honorable Prime Minister has given us a vision that we should be landing on the moon, that an Indian should land on the moon by 2040. This is a vision that he has given. But if it has to happen, then there are a lot of things that have to happen. We must go continuously to moon, then establish our robotic exploration, establish our base, then find out ways by which we can make use of that base for various scientific activities even before the man goes. So we are planning in various steps. We are asking this question to ourselves, to the industries, to the research establishment of this country, what you can do with moon. All of this vision cannot be created by ISRO alone. It has to be created as a national vision. That's what we think, that moon has to be a national program. See, the moon has been very important for all the nations now. So there has been a lot of moon missions announced by the US called the Artemis program. By the Chinese now, they are trying to establish a moon base. The Europeans are trying, the Japanese are trying. Their mission to land on the moon is on the way. So there is a large interest in moon due to many reasons. I will tell you the reasons. So the first and foremost is that you must go to moon and do more scientific experiments. So for that, we are planning a Chandrayaan-4 mission, where we have to develop a robotic activity of collecting samples and bringing to Earth. So this is the first attempt. But it's, though it's very simple looking, it's not a simple activity at all. Going there, drilling, collecting rock samples, bring it back, then bring it to Earth. Possibly you know that when Americans did the moon mission, they developed a huge rocket called Saturn. And we don't have that big a rocket. It had a power to take almost 100 tons to Earth orbit. That's how they could go to moon and come back. Today, our capacity to take only 10 tons to Earth orbit. It's only 1/10 of Saturn capacity. But we are not going to develop 100-ton capacity rocket. We are going to do very frugally, very ingenious way. And I will not tell you the secret how we are going to do today. We will announce the secret question later. We are going to do it with our available rocket, this experiment, not developing a new rocket. Without developing a new rocket, we will do this experiment. Then that is the uniqueness that is going to come out. Second is we have to do docking in space. Two satellites should come together and then connect and disconnect and again connect. So this experiment is also getting ready. It will be launched next year to demonstrate this docking. Then we have to develop a robotic arm to go drilling, take it the sample, put it in a container, pack it and send it to a satellite. So all this requires a very dexterous arm to do this. We have already developed it. It is available in our lab. All of you are welcome to come and see it if you can. Students are welcome to ISRO to see this dexterous arm design. So many technologies are required for docking, arm, robotic activity, propulsion, and many things are required. So we are developing all of them parallelly. And possibly you heard about the Chandrayaan Hope experiment. Did you hear? Many of you would have heard about it. That we did with the Vikram lander. After landing, we lifted it up once again, so that we can do a commanding from Earth and make the satellite come up from Moon back to Earth. Similarly, we did another experiment called moving the orbiter from Moon to Earth orbit. This also we did this time. So we got 3 outcomes out of a single Chandrayaan-3 mission for preparing ourselves for the Chandrayaan-4 mission. And many more things are going to happen in the Chandrayaan series. We will have Chandrayaan 5, 6, 7, 8. I don't know the number. How many are going to be there? It all depends on how many scientific establishments of this country are ready to build instruments, come out with an economic and business activity, how we can make use of the moon base for communication, navigation, research activities, zero gravity research, etc., and interplanetary missions. So we are trying to seek the help of all of you, all of the students, all of the research establishment, all of the industries in this country to come forward and help us.
Thank you so much for this insight, sir. This I'm sure is going to really inspire a lot of students that are here amongst us. But having said that, as we spoke, that India has grown leaps and bounds. The current government is really supporting ISRO, and there are some exciting challenges that we as a country are going to face. And as you said, that there are so many countries, the Europeans are there, NASA has been working, the Chinese have been working. As we speak about all of this, the low Earth orbit, or space, if I can say, it is becoming more commercialized. Now, what strategies is ISRO employing to ensure equitable access to space technology and its benefits for developing nations?
It is a very loaded question, and a lot of things are there to speak about it. One is that space is for everyone. This is the language we would like to speak. And we communicate it with all spacefaring nations. Space is for everyone. But then it is only a statement. In practicality, it is not true. There is a non-equitable distribution of resources in space. For example, you would have seen companies coming up with deploying thousands of satellites for global communication from LEO. But some of them are owned by Indians also, so we can be happy about that part. But then what happens is, there is a lot of debris created, a lot of satellites created. The sustainability becomes a major issue. And nobody follows rules. So the only way is to continue the dialogue between various actors, like the governmental organizations, institutions supporting space, so that they do some sort of a discipline in handling space sector. We should not cause weaponized space. It's one example, that you should not space as a tool for power. We should remove satellites who are defunct. We should also make a provision that we should not collide each other and create large number of debris. We should make sure that our rockets parts, after deploying the satellites, come back to Earth and get into sea. I think all these are important. And our contribution going to be that we are going to be the first example of all of this. And this is what we have decided. ISRO will show that we are going to demonstrate all these rules by ourselves. I think this is the first thing that we want to do. So we have not only that we made this statement, we also demonstrated. Last year we have deorbited 3 satellites. Many people don't know about it. And we have made sure all our rocket parts in orbit have come back to Earth already. So there is nothing left today in the geospatial orbit. Of course, in the low Earth orbit, some are left, which will take maybe 25 years, 30 years to come down, but not hundreds of years. We make sure we do passivation of all the stages, that we don't leave any gas or propellant inside, so it will not explode. And we make sure that we warn others in case of a collision possibility. So all these things we do so as to make sure that we follow the norms, we follow the best practices, we become an example of all those nations who are in space. And we invite all of them to be part of this journey like that. So that's all we can do, but we cannot do only preaching and don't do anything. I think that should not be the way. Yes.
Thank you so much. I would just want to add another thing, if you are comfortable sharing about it. We hear that India is also planning its own space station mission.
Yes.
And I think it is going to really, really inspire and empower a lot of our youth here. So if you could speak about that a little.
So that will be the Bharatiya Antariksha Station. We wanted to build using our present capability itself. So by 2028, we would like to have the first unit of the station launched. Using our present rockets, it will be something like 8 tons of mass. It will go to a low Earth orbit, but it will not be ready for taking human beings now to start with. So we will be a robotic space station. So we can send a space capsule there. It can get docked. It can transfer experiments using a robotic arms into it. Then it can return the experiments completed into the crew module and send it back to Earth. We can collect that back. So all of this will happen for next 5-6 years. And by 2035, we will be building further space station elements and make it fully functional by 2035. By the time, we believe that we will have enough capacity to handle human space flight on a regular basis. And this space station will be manned by Indians to conduct experiments, scientific research, etc. In fact, I was reviewing in ISRO the whole plan of it recently, just 1 week back, and a beautiful plan has come out from our team members, how to build this space station using our available technology at very low cost. I think that is very surprising thing, and we are going to really own it.
Thank you so much. The last question that I have for tonight, there are many more, but they're not as serious as the ones that I'm asking. We also want to know the person behind the science. So I think we'll get to that after this question. Now, AI is the advent of AI is talked about in all spheres of industries. So with the advent of AI and machine learning, how is ISRO integrating these advancements into its space missions for improved data analysis, decision making, mission success, and rural development, if I may ask?
You know, AI can be applied anywhere where there is enough of data. Actually, artificial intelligence comes out of analyzing data and making informed decisions based on patterns and trends that are there in the data. So this is the essence of the science. So we can use AI for various things. And we use it for, already we are using in space technology, AI is being used. Few examples I'll give you. Say we take image of the Earth using cameras and radars. And this image is a very big image. You take hundreds of kilometers in width and thousands of kilometers in length. And if you have to find out any meaning out of it, you need experts to analyze this data using computers for hours and hours together. But if you have an AI engine, AI machine, it can analyze the data and then tell us how this image is different from yesterday's image, or from last year's image, or 25 years back image, so that we can make an assessment on how the whole thing has changed. For example, urban growth. How many new buildings have come up in the last 1 year? How much of water in the river is lost? How much agriculture production has improved over last year? How many roads are newly built? And how much is the electricity usage in a town has increased? Even we can find even that. How is the climate and weather change is happening over a period of time? So many of these questions can be very quickly answered if you apply AI on images of satellites. We can use AI for detecting intruders, securing our borders, army movements, and many other things we can use. Ship identification, even submarine identification also. So this is one domain. Another domain we are applying AI is to find out health of a rocket. You know, when you launch a rocket, it goes up, and anything can happen to a rocket. It can get exploding, or it can get into deviation, get into some other country's direction it can go, and we will fail to destroy it. It will be a very big catastrophe. So we were trying to develop a technology by which if something happens to a rocket, it identifies itself and corrects itself. as much as it can. If it is not able to correct it, at least it should destroy itself. So this is called intelligence in a rocket. So we are applying AI to collect the data from the rocket various places and then use intelligence of AI to make those decisions. Even before any of us in the ground can make a decision, AI can make the decision. The third element, another experiment is in applying AI to find defects in materials, defects in propellants, defects in electronics production, and many production related issues can be handled using AI engines. So there are plenty of usages in AI, but of course you understand AI is a data driven thing. It will take many years to develop that skill over in various sectors, especially space sector, but we are on it. Thank you.
And I'm sure all of us wish you and your team at ISRO all the very best. Lastly, a couple of quick questions. As I said, we would really want to know the man behind the image of, Mr. S. Somnath. A quick few questions, if we can call it a rapid fire. Like, if you could choose any planet in our solar system to visit, just to visit, if you had the possibility, you could, which one would it be and why?
Mars.
All right, and why?
Mars is almost having the same gravity as Earth. If you go there, you will not fall down. And you will not jump like that you jump on the moon. You can walk normally. So that's one thing. The day on Mars is almost 24 hours. So I can sleep peacefully in the night. Okay. So it is not less or more than 24 hours, almost 24 hours. Then another most important thing is there is a possibility to convert Mars like Earth. There is something called terraforming, where you can, if you really want in 100 years, you can convert Mars like Earth. And there are technologies being developed for it. That's why Elon Musk is telling, I will create a Mars base of lack of people and then prepare Mars to become a colony. So if there is any other planet other than Earth where human beings can ever go, settle and create a colony, that's only Mars is possible. But something happened to Mars. Mars was once a habitable planet. So the more important thing for me is to find out why Mars, having water, air, everything, it got depleted all on a sudden, or maybe over a period of time. So it can happen to Earth also. If you are not careful, if you are not handling the ecology, the changes in the climate, etc. properly, it can happen to Earth also. Earth will also become like Mars, very dry place, no air, no oxygen in the atmosphere, no water.
And if I may ask, do you think global warming could play a role in that?
Yes, of course it can cause havoc in that. The entire ocean can dry out if you are not careful. If the ocean dry out, your atmosphere can be lost forever. So there are very subtle balances existing between the heat that comes into Earth, the evaporation losses, the air that is maintained here. Everything has a connection. If some balance goes, then everything can be lost. So it happened to Mars. It had thick atmosphere once, but why it suddenly depleted? Nobody knows. So this is something that we need to understand. So for understanding purpose itself, I want to go to Mars.
And if you could organize a dinner party with any 3 scientists who are dead or alive, who would they be?
First one is our mathematician, famous mathematician of India. You know him? Who will name that famous mathematician of India who never got a Nobel Prize? Ramanujam. So the type of brilliance that he had is something phenomenal. A person who has not studied it very well, but still he managed to learn mathematics and solve complex problems. Second, of course, is Albert Einstein. Why? Is because he made such a phenomenal contribution in his early life. Maybe when he was 22, 27 years of age, he found out most of the theorems that is led to the understanding the universe. The theory of the special theory of relativity, the theory of relativity, the theory of photonics, and then he tried to create the general theory of relativity, and then he tried to integrate all of this into single theory of the science physics. And towards his life ending, he started looking at various complex problems and fought with even Heisenberg uncertainty principle. I don't know still why he fought with Heisenberg on uncertainty principle. I still do not understand. Because he said that God doesn't play with dice, is his great statement, which was proved to be wrong. So even Einstein went wrong towards his last phase of his life. So I would like to ask him what went wrong with you. Then of course, the another great scientist is nobody other than the one who generated so much of interest in electricity, magnetism, and the whole of all that you enjoy today, Edison. I think his phenomenal impact on developing technologies, not science alone, converting the fundamentals into technology that paved way for thousands of new innovations that came to us in the form of devices, equipments, etc.
I would want to thank Mr. Edison too, because he invented the camera.
Yes.
And a lot of what I do today is because of him. So I can definitely understand you.
Thank you. So each one of them has a reason. Srinivasa Ramanujam died at very early age because of a disease. If he had lived for another 50 years, I do not know what he would have found out. Such a phenomenal impact in mathematics domain.
And the last question is, I think a lot of people, there have been movies made on it. There's so much has been written all over these years about extraterrestrials. What if you end up encountering an extraterrestrial? What message would you want to give to that entity on behalf of humanity?
Anybody has a doubt that there are ETs available or not available? You have any doubt that they are there or not there?
I don't know. If you're asking me personally, I mean it's a good food for thought. I mean
no, but I am very sure they are there. So extraterrestrial means the people who are coming from some other planet. I think that also tells in a way that there is life beyond Earth. So these are questions which we need to connect each other. There are always possibility that there is life beyond Earth, because we have found out almost 5,000 planets like Earth, so moving around other stars, and at least hundreds of them have possibility of having life.
So debunking the theory of having extraterrestrials, I think we shouldn't debunk that possibility.
We should never, because we do not know. See, we think that we are technologically very advanced and we know everything. I think it is a foolish thought. The first thing you have to realize that you have this ability to even communicate came only in 100 years. The electromagnetism, the ability to speak through the mic and get it in a large amplified capacities came just 70, 80 years back, not many years back, maybe 100 years. And you can send a signal to moon and get it back. The whole thing came just 100 years back. We understood how electromagnetism works. And you are telling that you know everything. But there could be some extraterrestrial who understood maybe another 100 years better than you. I don't know what all technologies they have. And they would have already knowing what you are speaking here. And so there is a possibility that they are around. But if they are around and if I am ever possible to meet them, one thing is very sure, they are far advanced than us. If they come here and if I had getting a chance to meet them, they came here from far off places which are hundreds of light years away. That means they know the technology to travel light years apart. That means they are really advanced. And they are coming here not to harm us, but to look at us as creatures. No, they are not developed creatures. And they will not even mind me speaking to them if they are so accommodative. And I would like to ask them the fundamental question, where is your technology? Can you share with me? So that I can accelerate the growth of our humanity. So that's the question which I will tell them. And if they are gracious enough, possibly they may tell me the secret. Huh?
Ladies and gentlemen, I would want to sum it up in typical filmy style. People down south, they say mega star, superstar. I would want to sort of, attribute our very own Mr. S. Somnath, the fire star, rocket star, propulsion star, ladies and gentlemen, Mr. S. Somnath. Please give it up for him. Thank you so much.
Thank you so much for this opportunity to speak to you and meet you. Thank you so much.